now we're ready to build a simple circuit. Here's what you're going to need for this part. You're going to need your Arduino board, and then also a breadboard. That's this white rectangle with lots of little holes in it. You'll need one LED. You get to pick which color. You'll need a 220 ohm resistor. If you look in your box, you will find a lot of resistors, and you'll notice that they are marked on the end. So you can use 220. Actually, if you use 330, it probably wouldn't matter, but if you use one of the really big ones, your LED will be very dim. You'll also need a couple of wires and your USB connector and your computer. Before we dive into this, let's talk about a circuit itself. And I am not an electrical engineer, so we're going to keep it really simple. Basically, there are three required parts of a circuit, which are a power source, like a battery, or in this case, our Arduino. You're going to need an electrical path for the electricity to follow. This will start at the positive or plus. On our Arduino, it'll be 5 volt or 3 1/3 volt. And then it'll go to ground, which is minus. And then we'll need some kind of load for the electricity to use. In this case, we'll be using an LED and a resistor as our load. And then optionally, you could have something to control your circuit, like a switch. And later, we'll be using the Arduino to control our circuit. Let's do a sample of that. We're going to start with a power source. And for our purposes today, we could use a battery as an example. When we build our circuit, we're going to use an Arduino as our power source. But for this discussion, let's keep it real simple. So here is a battery. And then our circuit will also need a load, which is something for the electricity to do. And finally, our circuit will need some electrical pathways for the current to follow. We now have the three pieces that we need for a simple circuit. We have the power source, we have the electrical pathways, and we have something for the circuit to do. One of the problems with the circuit that I've built here is what holds the wires together. So for example, what holds the wire onto the plus end of the battery or the negative end of the battery? What holds the wires onto the feet of the LED? We could solder it together. We could come up with different strategies for doing that, but there is an easy way to create circuits quickly without using solder, and that's to use a breadboard. And so here you can see a breadboard and what they look like. And I need to quickly explain how you use a breadboard. The idea being that you can plug different components or wires into the holes in the breadboard, and it'll allow you to tie them together. So for example, if I was to click on one of the holes in these rows of holes here, all of these are tied together vertically. So if I click this one, you can see that all of the holes in that column light up. Here I'm going to click this one, you can see all the holes in that column light up. So when I'm dealing with this particular area of the breadboard, they're all tied together. There's a gutter in the breadboard. The gutter is to remind you that the current does not pass from the top section to the other section. So if I'm clicking here in the top section, the current would not jump to the bottom section. But if I click somewhere in the bottom section, that's a new set of 5 holes that are independent. And then on the ends, you can see you have a red line and a blue line. Those are tied together all the way across, and we'll talk about those later. We're not going to use those ends today, but they are tied the length of the board. So here, if I click on one of the pinholes on the blue line, it's going to light up all the way across. Same for the red line, same for the blue line, same for the red line. And I'm going to go ahead and plug the LED into my breadboard. When you look at your LEDs, you'll notice that one leg is longer than the other. And this is because LEDs can only handle current from one direction. LED stands for light emitting diode, and diodes are one directional, meaning current has to come in the plus side and leave on the negative side. If the current tries to come in on the negative side, the diode will resist it entering unless the current is too strong for it, and then it will just destroy the diode. And now you can see that when I moved the LED onto the breadboard, it highlighted in light green where the two pins went. So this is my negative pin of my LED, this is the positive pin of my LED, and I can take a wire and bring it over and drop it onto one of the pins in that row. So I'll take the negative wire and put it into one of the pins in the negative column of the LED, and now my circuit is still complete, but it's a lot easier to hold things together when I'm using the breadboard. For this exercise, we're basically going to build this circuit using the Arduino. So here's my Arduino single board computer, and we're going to tie the circuit into the Arduino and use it as the power source. So I can disconnect my wire, and we'll take the battery away. Let me remove the wires for now. In our case, we want to run power from our Arduino to our light emitting diode. So on our Arduino, if you look closely, you can find a 5-volt pin. We're going to take a wire. It doesn't matter which wire you use, they're all just wires, but I try to color code just a little bit when I'm working. So my red wire is going to stand for positive, my black wire is going to stand for negative. So I'm going to attach my red wire to the 5-volt pin and run it to the long pin on my LED. Let me change the wire color there. So that will provide current to the LED, but now I have a different problem, and that is that 5 volts is likely too much current for our small LED. And if we give it too much current without protecting it, it will shine very brightly for a little while and then it will burn out. So what I want to do is add a resistor, and the resistor will give us some additional load so that the LED doesn't take the full brunt of the current that we give it. So here I'm going to bring in a resistor. I'm going to put it on the negative side of my LED. I'm going to take a ground wire, attach it to the LED, and go to one of the pins marked ground on my Arduino Uno. So this is what the circuit looks like that we want to build. If you built it successfully, when you plug the Uno in, it should light up the LED. And the reason is that the Uno is not doing anything at this point except for providing power to the circuit. We don't have to write any code for it. The 5-volt pin constantly provides 5 volts out from the Uno, and the ground pin is always accepting current as ground. So this circuit should work just by plugging the Uno in to give it power. At this point, you'll need to go ahead and build this circuit. You can pause the video with this circuit visible so that you can see what you need to do. Also, the resistors, when they come, are very straight. You will need to bend the pins or bend the little wires at the ends of the resistor into a 90-degree angle so that it can go into your breadboard. It does not matter which particular sets of wires you use. The circuit will work the same regardless of what set of columns you use, but you need to do the circuit correctly as far as the long pin to the LED is connected to the 5-volt. The resistor is connected to the short pin of the LED and also connected to the other wire, which is going to ground. Incidentally, the resistors are bidirectional, so it doesn't really matter which way you put the resistor. It'll work the same either way. Go ahead and pause the video and keep that on the screen, and go ahead and build your circuits and test them, and let's see what happens. Welcome back. Hopefully all your circuits are working. As we work through different circuits, I will be providing you a wiring diagram that looks similar to the one that's here, so that you can see what to do as far as building the circuits. And then if there's code needed, we will also be providing the code that you would put into your Arduino so that you can compare what you typed to what I did, and if there's a problem, then you'll know how to fix it. What we'll do next is let's get the Arduino involved, and we'll program the Arduino so that it can control the LED. And in this case, what we'll do is have it flash the LED on and off.